Assalamualaikum. This is a continuation of our notes 5.2.2 Stereoisomerism. Molecules have same molecular formula and structural formula, but different orientation of atoms in space within the molecules. Same connectivity of the atoms. Each isomer has different physical, chemical, and biological properties. So this is the same as the constitutional ataupun structural isomer. So example, butene acid, the cis isomer is called malic acid, and trans isomer is called fumaric acid. So this is the structure of your butene dioxide acid. So it has a double bond here, and also a carboxylic acid functional group. So the trans isomer. So this is the trans sebab here is your carboxylic and here is your carboxylic. So you have carboxylic at a trans position. So this is a trans of the butanoic acid, whereas this is your cis of your butanoic acid. This is a cis transition. So fumaric acid trans isomer, the melting point is 287. Essential metabolite intermediate in both plants and animals. That's the function of this fumaric acid. Whereas for the malic, which is your cis isomer, the melting point is only 138, toxic and irritating to tissues. So what's the difference? Why is the melting point of both of these compounds are different, even though it has the same molecular formula? Okay, stereoisomerism. It can be divided into two groups: geometrical isomerism and optical isomerism. First one, geometrical isomers. The presence of a carbon-carbon double bond or cyclic structure prevents the rotation of the carbon atoms. So example, C4H8. So this is your double bond. This is your trans formula, transposition. So it's transverse each other. Trans to butene. All substituents are methylene on the opposite sides of the double bond. Whereas for your cis, both of your R substituents are on the same side of the double bond. Okay, if the structure has a single bond in its structure, free rotation, it can rotate its bonding position here. On a single bond, same molecule, no isomer. So it cannot make an isomer of cis and trans. It only has a single bond in the structure. Whereas no rotation on a double bond, different molecule. So isomerism exists. So if you have a double bond in your molecule, it cannot rotate. So bila tak nak, so when it cannot rotate, so it can make two different structures, which is your trans and this is your cis. Cyclic compounds also show cis and trans. So for example, C5H10O2. So this is your trans. Okay, actually it has to be written this way. Okay, so sepatutnya satu solid, satu lagi yang apa tu? Satu solid, satu yang hashes tu. Hash. So you can see it's in a trans position. Sebab satu solid wedges, satu lagi dashed line tu, dash line tu. So a cis, kalau cis dia boleh dua-dua solid wedges tu, dua solid wedges, ataupun dua-dua dalam bentuk hash tu, dash. So both can be considered as a cis transition. Okay, so yang ni cis. So yang ni, it shows single bond. Single bond, so dia tak boleh rotate dekat situ. Bila tak boleh rotate, dia akan menunjukkan. So if you have a structure, a cyclic structure, which has no double bond here, but it cannot rotate. So it can make a isomer, either a cis or a trans. So kalau contohnya ni, dia ada wedges, solid dengan dashes. So it make a trans isomer. OH groups are on the opposite side. So macam ni lah contohnya tadi tu. So it should have a wedges, solid wedges and a dashes line tu. Dashed line tu on opposite sides. So we know it's on opposite sides of the plane. So whereas if you have both of the substituents having the same linkage, so this is the dashed line, both, and both of these are the wedges. So it will make a cis transition, cis isomer, OH group on the same side. Okay, conditions for geometrical isomerism contains at least one double bond, CC. There must be two different groups attached to each carbon on C double bond C. So contohnya yang ni. So you have a double bond here. Okay, the first syarat is completed. But for the second one, you have to have two different groups attached. So kamu tengok ni, carbon yang pertama ni, the first carbon and the second carbon. Okay, the first carbon has both of the methyl group on the same side. For the second carbon, hydrogen on the same side. So it cannot make a geometrical isomer. Benda ni kena carbon pada yang carbon pertama kena ada dua-dua yang berlainan. Cannot have both of the same substituents on the same carbon. So for example, this one, CH3 and H on carbon 1, carbon 2, H and methyl on the carbon 2. So it has a different substituent on carbon. It has a different substituent. This is methyl, this is hydrogen. So carbon 1 have two different substituents on its carbon, attached to its carbon. So the same goes to the carbon 2. So when you have both methyl group on the same side, so this is a cis isomer. Lepas tu yang ni pun sama juga. You have a different substituent on the same carbon. So carbon 1, carbon 2. So carbon 1 ada CH3 and H, carbon 2 ada CH3 and H. So we're having a different substituents on the same carbon. So this is a trans because the methyl group is on the opposite side. Okay, tri-substituted or tetra-substituted double bond. So the first syarat is you have to have a double bond. So the first syarat is completed. So the question is, why methyl on opposite side is cis? Ini, kita tengok kat sini. You have a methyl group here on carbon 1 and you have a 1, 2, 3. So you have a propyl group here. This is propyl. This is your methyl. This is your hydrogen. This is your methyl. So you have a methyl on the opposite side, but why not? But how come it is a cis? Okay, the thing is because you have 4 different groups sekarang. 1, 2, 3. Sorry, you have 3 different substituents. You have a methyl, you have a propyl, and you have an hydrogen. So in this case, you have to look for the higher molecular weight. So untuk carbon 1, compare both of these substituents. For carbon 1, you have to compare both of the substituents. So substituent yang pertama, methyl, compared with the propyl. Which one having the highest molecular weight? So the propyl will have the higher molecular weight compared to your carbon, to your methyl on carbon 1. For carbon 2, you will have, methyl along with your hydrogen. So which will have a highest molecular weight? So this methyl will have a high molecular weight compared to your hydrogen. So what will happen? See, you have both of your low molecular weights on the same side and higher molecular weight on the same side. So that why is called a cis. This compound named as a cis because the propyl group and methyl group are higher molecular weight and are at the same side. So sama juga untuk yang structure yang ni. So structure yang ni methyl, methyl, hydrogen, propyl. So this is much higher compared to this one. And this one is much higher compared to this one. So you have a higher dengan higher at a transverse location. So ni high low, low high. So high dengan high kamu pada trans position. So this compound names as trans because the propyl group and methyl group are at the opposite side. Okay. Optical isomer. A molecule which has a stereocenter chiral carbon atom or asymmetric compound. Chiral carbon atom has 4 different atoms or groups of atoms attached to it. Enantiomers are chiral molecules that are mirror images of one another but cannot superimpose. Enantiomers are optically active. So this is, I give you the link of YouTube so you can understand more on this optical isomers because benda ni kena tengok 3D dia baru nampak. So later on I will show you this video. Okay, non-superimposed. Okay, let's say this is your compound. You have carbon with a H, with a Cl, with a methyl and with an ethyl as the substituents. So ini ialah mirror kamu. So this is the image of your compound. This is your original. This is your image. Okay. Sekarang kalau kamu nak superimposekan both of these molecules, okay. This is the original, this is the image. Okay. Contohnya image ni kita pusingkan dia. This is the mirror image rotated 180. So at original position, the ethyl group is on the right side. Yang ni ke depan, pandangan depan kita. Ni pandangan belakang kita. Okay, so when you rotate this image to 180, so maksudnya kita rotate garis lurus. So this will be, the ethyl group will be on the left side. So the methyl group will be up front. Yang chlorine ni akan berada di belakang. So bila yang ini di overlap dengan original dia, dia tak akan overlap cantik. Tak akan jadi. Hydrogen saja yang akan overlap cantik. Hydrogen dengan methyl. So not all of the substituents can be superimposed. So enantiomers are in mirror image of each other that cannot superimpose. So meaning this compound is a chiral compound, is an enantiomer. Okay, chiral carbon. So chiral carbon, it has to have 4 different substituents on its attachment. So contohnya carbonnya ni. So having a green, yellow, red and a blue substituent. So meaning it has 4 different substituents kat situ. So this is the mirror image. So mirror image ni bila kita rotate, katakanlah kita rotatekan benda tu. Okay, katakanlah kita terus overlap kat sini, tak akan dapat overlap yang cantik. Dia akan dapat overlap merah dengan hijau sahaja. Dia punya substituent. But for the yellow and for the blue cannot be overlap nicely. Okay, this is another example of your chiral carbon. Okay, the left and the right hands are non-superimposable mirror image of each other. So this is your left hand. This is your image of your left hand. Cuba terbalikkan image ni, dia akan jadi right hand punya tangan. Image. Dan right hand punya tangan, cuba overlapkan dengan yang left hand. So kamu tak akan dapat benda yang sama. Dia tak akan dapat superimpose. So it is non-superimposed image of your hands. Okay, example. So still the same thing. This is your mirror. So this is your chiral carbon because you have 4 different substituents on the same carbon. So this is your mirror image of this compound. So ethyl kamu akan ada di sebelah sini. OH, H, CH3 akan berada di atas. So this is your mirror image of your compound. So compound ni cuba overlap dengan, okay, kamu nak rotate, tak nak rotate pun tak apa. Cuba kalau tak nak rotate. So just overlapkan benda tu dekat sini. So dia takkan overlap cantik pun. Even if you rotate this compound, let's say lah, if you want to rotate this compound 180 degrees. So CH2 will be on your right. Okay, dia akan sama kat sini. H akan berada di belakang. Tapi OH akan berada di dapat rotate ke? Cuba pusingkan. Okay, cuba kita pusingkan. So CH3 akan berada di sini. Kita pusingkan 180. So C masih di sini. So let's say if you want, if you want to rotate this one to this way. So ini akan berada di, dia akan jadi wedges tu. C2H5. Okay, dia akan pusing ke situ. Yang ni akan ke belakang. Salah. This will be normal line. This will be your dash line tu. H. And this will be your macam mana? Tak apa, nanti kita tengok video tu. Okay. Chiral drug. There's something about this chiral that affect the life previously lah. A chiral drug, a sad story of thalidomide. Thalidomide was used as anti-nausea for pregnant women. From 50s to 60s, it was sold as racemic mixture. Racemic maksudnya dia ada dua-dua position. R dengan S, dia ada dua isomer dalam tu, campuran. In 61, it was withdrawn from the market due to this effect. So, bila dia buat ubat, dia buat campuran dua-dua ni. Okay. Let's identify where is your chiral carbon first. Okay. Chiral carbon, what is the rule of chiral carbon? You need to have 4 different substituents on the same carbon. The carbon has to have 4 different substituents. Okay. Contohnya kita ambil yang kat sini. C. Okay. You have H dekat sini. And you have attachment of C dekat sini. And you have another attachment of C dekat sini. Okay. The first rule is you have to have 4 substituents. Meaning, your chiral carbon has to have a single bond. Semua kena ada single bond. sp3. Dia kena bentuk sp3. Okay. Alkene pula. Aromatic ring cannot make a chiral carbon because yang ni semua sp2. So it cannot make a chiral carbon. So ignore the whole aromatic ring kat sini. So tengok kat sini juga. Kalau kan tengok kat sini, C tu ada double bond. So this is also an sp2. Ignore. So this is not a chiral carbon. The whole aromatic ring is not a chiral carbon. This is also not a chiral carbon. This is also not a chiral carbon because it's having a double bond kat situ. This might be, yang ni mungkin boleh jadi chiral carbon sebab dia ada attach dengan H. Dia attach dengan C dekat situ. CH2 kat situ kan. So yang ni dia akan attach dengan C double bond O. Dia buat attachment dekat situ. Okay, carbon sini pun dia attach kepada CN. Dia attach kepada H. Dan dia attach kepada CH2. Okay, but the priority is here. This is your isometric center. Sebab kat situ bila buka dia punya structure, so C ni akan attach directly to N. So directly to H. Kan kat dalam tu ada H satu. So yang C ni akan attach kepada C double bond O. Here. C double bond O. Another one is here. C H. So you have 4 different substituents on the same carbon. So this is your chiral carbon. So this is your chiral carbon, asymmetric center. Okay. The thing is about this drug, both of the isomers are there. Dia campurkan dua-dua. Isomer dekat apa ni, yang solid wedges ada, dengan dotted wedges pun ada. So what's the property? What is the function of this linkage? Okay. If you have a solid wedges, so the drug has a sedative properties. But when you have the dotted wedges, it is a teratogenic, cause horrible birth defects, deformed limbs. So if let's say a woman consume this drug, which have both of these compounds in the same drug, so the drug have a sedative properties. At the same time, yang pregnant woman ni pergi makan ubat ni, deform limb. So anak dalam kandungan tu bila lahir dapat macam ni. So that's the effect of mixture kat sini. So actually in order for the pharmacists or for the scientists to produce a drug, so they have to make sure that the drug doesn't have properties yang bercanggah. This is a good one, this is a bad one. But if that person consume this drug, so both of the side effects will be on the same drug. So perempuan ni akan dapat sedative effect. At the same time, anak dia akan cacat. Due to the central chiral carbon yang berbeza dekat sini. Just because of this ni wedges dengan yang dotted ni. Just because of that linkage makes the drug bad. Okay. Checkpoint 5, question 1. So I won't give you the answers now. We are going to discuss the answers during our discussion later on. Okay. Okay. So that's it for now.